Assalamualaikum warahmatullahi taala wabarakatuh and a very good day to you. My name is Muhammad Fakhrul Ali bin Othman from AS2295B. So today my group and I will present to you about the whole body vibration on heavy equipment vehicle workers. Okay, let's get started. Imagine the daily grind of truck and heavy equipment vehicle drivers, the backbone of our industrial landscape. These individuals command massive vehicles, navigating through challenging terrain, enduring long hours, and facing unpredictable weather conditions. They are the unsung heroes who move the gears of our economy. Today, we shift our focus to the occupational health and of these dedicated drivers, a group exposed to a unique set of challenges that demand our attention. Today's exploration takes us into a vital realm of occupational health, the pervasive whole body vibrations experienced by our hardworking truck and heavy equipment vehicle drivers. Beyond the visible expression, these issues goes to the core of their well-being and job satisfaction. It is not just a concern for individuals, it is a matter that ripples through the very fabric of our industry. The vibration this driver endure daily extend beyond the steering wheel. They impact the overall safety and welfare of those who keep our supply chains moving seamlessly. Before we move any further, what is the whole body vibration? The whole body vibration refers to the mechanical vibration that are transmitted to the entire body while operating a vibrating vehicle, such as a truck. This vibration can range from low to high frequency and can have various effects on the human body, including musculoskeletal disorder, increased fatigue, and decreased overall well-being. It is important to understand and address the impact of whole body vibration on truck or heavy equipment vehicle drivers' health and implement strategies to minimize its negative effects.
Problem statement. Exposure to the whole body vibration (WBV) poses a significant health risk to the truck drivers, leading to various physical problems such as low back pain, slip disc, and nerve damage. Also, the higher the exposure to WBV can cause a micro-fracture in the vertebrae and lower back pain that can impact the overall well-being of the truck drivers. Research has shown that WBV is documented for exposure among driving population and can contribute to the beginning and development of the low back disorder. Professional truck drivers are regularly exposed to continuous WBV and leading for the risk factor like a low back pain. Besides, the impact of different seat and WBV exposure on the truck driver's discomfort has been studied. Therefore, exposure to WBV can increase physical and mental failure that become common issue faced by the professional truck drivers. Additionally, WBV can impact the overall health and safety of the truck drivers. For objective, number 1 is to awareness the truck drivers about damaging effect of vibration on the body, explanation about the cause of the whole body vibration WBV, and describe method to reduce it. Number 2 is to determine the effect of WBV exposure on the truck driver's discomfort and the impact of different seat in truck. Number 3, to elevate the mitigation measures such as reducing travel speed, rest break schedule, obtaining information on equipment vibration, recommended maintenance schedule, and improving vehicle suspension to reduce and minimize the WBV exposure.
For this methodology, in this article, the field test was carried out in Porcuna in Spain. Several drivers of this type of vehicle working in the area were interviewed. Based on the obtained information, a typical work cycle for this type of driver was identified. As a result of this process, the selected route was representative of the complete work cycle and comprised different types of surfaces. The route had a length of 10.5 km, comprising 1.5 km off-road, 3.3 plus 2.5 km of unpaved road, which is two different types were considered, and 3.5 km of tarmac road. In measurement equipment, the SV38 Vantage tri-axial seat pad accelerometer was used to measure the acceleration transmitted between the seat and the driver as shown in the figure. This accelerometer measures the signal in the x-axis, which explains for front to rear driver, while y-axis for left to right driver, and z-axis as well for buttocks to head driver. A comparative case according to the short and long-term exposure assessment methodology defined in ISO 26311 and ISO 26315 applies the methodologies defined in ISO 26311 in 1997 and ISO 26315 in 2018 to assess the level of whole-body vibration exposure experienced by drivers of heavy equipment vehicles. The study aims to analyze the prediction of health risks associated with heavy equipment vehicle activities and compare the obtained health risk assessment between drivers with different anthropometric characteristics. The methods used in the study include the root mean square value A8 method and the vibration dose value method defined in ISO 26311 in 1997, as well as the method defined in ISO 26315 2018, which includes the factor R to assess the adverse health effects of long-term whole-body multiple shock exposure.
Assalamualaikum, my name is Farid bin Habibul Mutsidin from class AS2295B. I will discuss about the result and discussion regarding this study. Based on the results presented in the study, it is evident that whole body vibration exposure poses potential health risks to drivers of heavy equipment vehicles. The analysis conducted according to ISO 2631:1997 and Directive 2002 revealed varying levels of vibration magnitude across different surfaces and drivers. The comparison of results obtained from different whole-body vibration assessment methods, as depicted in Figure 5, highlights the significance of these variations in assessing the potential health effect on drivers. The study indicates that the vibration dose value method, in particular, identify adverse health effects for driver 1 on specific surfaces, while the A8 method did not indicate exposure levels detrimental to the driver's health. This discrepancy underscores the importance of utilizing comprehensive assessment methodologies to accurately evaluate the impact of whole-body vibration exposure on the drivers. Furthermore, the influence of factors such as surface type and forward speed on the magnitude of whole-body vibration exposure emphasizes the need for a nuanced approach to assessing and mitigating these risks. Moreover, the comparison between the limits set in Directive 2002 and ISO 2631:2018 reveals discrepancies, with the former being more restrictive than the latter. This finding underscores the necessity of revising and harmonizing the standards to ensure the effective protection of drivers against the potential adverse health effects of whole-body vibration exposure. The study's recommendation for the revision of the limits defined in ISO 2631:2018 aligns with previous research, indicating the need of ongoing refinement of standards to reflect the latest scientific understanding and ensure the well-being of drivers. In light of these findings, it is imperative for regulatory bodies and industry stakeholders to consider the implications of whole-body vibration exposure on drivers of heavy equipment vehicles. Implementing measures such as regular health assessment for drivers, ergonomic seat design, and vehicle maintenance protocols can help mitigate the potential health risks associated with whole body vibration exposure. Additionally, ongoing research and collaboration between relevant stakeholders are essential to inform the development of updated standards and guidelines that effectively safeguard the health and well-being of drivers exposed to whole body vibration. Overall, the study's findings underscore the complex nature of whole body vibration exposure assessment and the need for a multifaceted approach to address the potential health risks faced by the drivers of heavy equipment vehicles. By considering the nuanced interplay of factors influencing whole body vibration exposure and advocating for the refinement of assessment standards, the study contributes valuable insights to the ongoing efforts aimed at ensuring the safety and well-being of drivers in this occupational setting.
As a conclusion, the study found that driving heavy equipment vehicles can expose workers to the whole body vibration, which can lead to health problems like musculoskeletal disorder. The study compared different methods for assessing short and long-term whole body vibration exposure and found that the risk assessment can vary depending on the driver's body size. This means the driver with larger body size may be at a higher risk of adverse health effect from whole body vibration exposure. The study suggests that there is a need to update the current limits for safe exposure to whole body vibration, especially for drivers with larger body size. It also highlights the importance of implementing whole body vibration health protection program to ensure the safety and health of heavy equipment vehicle drivers. Further research is recommended to better understand and address this issue with a focus on exposure assessment using the latest standards. Overall, the study emphasized the significance of considering long-term whole-body vibration exposure to protect the health and safety of heavy equipment vehicle drivers. So, that's all from us. Thank you.